Struggling with binary conversions? Let's make it simple. Did you know every IP address hides a secret binary code? If you can't read it, you could struggle with networking and certification exams. But don't worry, we've got you covered. In just a few minutes, you'll master the fastest, simplest way to convert decimal to binary. No confusion. No stress, just results. Want to turn 192.168.1.6 into binary like a pro? Watch now and level up your skills.
The decimal system is the numbering system used in everyday mathematics, and the binary system is used in the computer world. Network devices use the binary system to define their location on the network. Understanding the basics of the binary system will go a long way in helping you understand the network. In the decimal system, which is used very frequently, the digits range from 0 to 9. After, it's from 10 to 99. And we start again with the number 100, while increasing by +1 each time, and so on. In the binary system, only the digits 0 and 1 are used. The first number is 0, followed by 1, then the number 10, 11, 100, 101, and so on. Here you see the binary conversion of the decimal digits from 0 to 19. To convert decimals to binary, you have to use a very specific process, that of the powers of 2. In the first line of the table, you have the powers of 2, and just below the decimal values of these powers. As an example, we will convert the number 35 into binary. Looking at the table, from left to right, you have to ask yourself which is the greatest power of 2, which is less than or equal to 35. 128 is greater than 35, so we put a 0. 64 is also greater than 35, so it will also be a 0 below. On the other hand, 32 is less than 35. Since it is less than or equal to 35, we put a 1 below. Then we have to calculate the quantity that remains by subtracting 32 from 35. We continue with the same logic, always from left to right, but this time with the number 3. 16 is greater than the number 3. We will therefore put a 0. 8 is also greater than 3, so it will be a 0. After is 4. We also put a 0. As for the next number, the 2, it is less than or equal to 3. This time we put a 1. We subtract 2 from the number 3, and now we just have to find the number 1. The decimal value of the last bit is 1, which is the remaining number. We will therefore put a 1 below. The binary equivalent of the number decimal 35 is 0010011. An IP address takes the form of 4 sets of decimal numbers separated by periods. The decimal number in each set is between 0 and 255. Each party is 1 byte. So there are 4 bytes in an IP address. All computer systems understand IP addresses only in binary form. We will now translate this IP address into binary. The easiest way to translate from a decimal to binary is to start by writing the powers of 2 for each part of our IP address. Now we just have to apply the method we used for the number 35. The value of the first set is 192. This is the addition of 128 and 64. Then we have 168, which is the addition of 128 plus 32 plus 8. The 1 corresponds only to the power furthest to the right, and the 6 is the sum of 4 plus 2. Feel free to practice binary conversion at home and check the result on Google using any converter you can find. It is very important to know how to convert any IP address yourself, especially for the CCNA.